In the name of Almighty God, the most compassionate and the most merciful, I welcome you all, my dear friends from all over the world. Welcome to our new chapter on binomial expansion. By the way, in binomial expansion, what we will talk in this chapter, first we will have an introduction. That what binomial expansion is. Second, we will have Pascal triangles for finding the coefficients of a binomial expansion. And number 3, we will have a proof of binomial expansion. Binomial expansion by usage of mathematical induction, inshallah. And number 4, how we can define the general and middle term in binomial expansion. Binomial expansion. With all the special cases. And number 5, we will have inshallah application with examples or numerical on binomial expansion. It's a very great chapter, and with the examples, with the tricky examples we will have inshallah in this chapter. By the way, find a place and pick up a notebook with a pen. Just first listen what I lecture. Second, pause the lecture and then write all the details which we write down on the board. By the way, take it please. We will come inshallah on this lecture. By the way, come to introduction. First, you have to know that whenever we are talking about a plus b whole square, what this one means, this means that a plus b multiplied by a plus b. Am I right or not? Yes. Then how can you multiply these two terms? First term should be multiplied with these two, and the second term should be multiplied with this one. A times a, it is a square. Positive times positive, it's positive. And a times b, it's ab plus b square. I am sure that you know. Then we can have a plus b whole square is a square plus ab with ab, it is 2ab plus b square. Am I right? Yes. Whenever you're talking about a plus b whole raised to the power 3, it means a plus b square times a plus b. Now, you know the result of this one. This is a square plus 2ab plus b square times a plus b. Now, if you multiply this one with this one, you will find the result a plus b whole raised to the power 3. It is a cube plus 3a square b plus 3ab square plus b cube. Am I right or not? Multiply this one and you will find. If you have a plus b whole raised to the power 4, then it means a plus b raised to the power 2, a plus b raised to the power 2. You know the result of this one. It is a square plus 2ab plus b square multiplied with this term. It is a square plus 2ab plus b square. Then you have to find this one. This is a simple way that we have in multiplication case. But if you have a plus b raised to the power 16, then what does it mean? It means a plus b raised to the power 8, a plus b raised to the power 8. Now this one means a plus b raised to the power 4, and this is once again a plus b raised to the power 4. This term also it's the same, a plus b raised to the power 4, a plus b raised to the power 4. Now if you multiply all of these terms, it would be much difficult. For this result, we do not use this multiplication case. We are coming for our new lectures or new chapter, that is binomial expansion. Write it. We will proceed inshallah. By the way, you know one thing, that is, what is binom? Binom means we have two terms in sum or subtraction. What do I mean? For example, if I have x plus y, this is a binom. If I have x squared plus y cubed, this is a binom. If I have x cubed minus y cubed, this is a binom. What is binomial expansion? Whenever you are talking binomial expansion, it means that this binom x plus y should raise to a power. For example, 4, 5, whatever it is. If we have x squared plus y cubed raised to the power 5, then this is a binomial expansion or binomial theorem. For binomial expansion, just for which index, for which power? For positive integer indices of the binomial expansion, if we have x plus y raised to the power n, this n should be what? Should be a positive number, and it should be an integer number. It means x plus y raised to the power 5. Then this is correct. X plus y raised to the power 5.1. It is not correct. Why? 5.1 is not an integer number. It is a fraction. If you have this n, it should be a positive integer indexes. Now you can use this formula, nc0 plus nc0 x to the power n plus nc1 x to the power n minus 1 y, nc2 x to the power n minus 2 y to the power 2, nc3 x to the power n minus 3 y raised to the power 3 up to n cn y raised to the power n. This is the general formula that we can use for the which binomial expansion for positive integer indices. You can use this formula. According to this formula, you can solve all the questions. For example, if you have x plus y raised to the power 1, now use this formula. N is 1, c 0, x to the power n is 1, plus n is 1, c 1, x to the power n minus 1, 1 minus 1, and y to the power 1. Am I right? Yes. Now, if you simplify this one, what 1c0 means? It means the combination 1 by 0. X to the power 1 plus 1 by 1. This is the combination. X to the power 1 minus 1, it is 0. And y to the power 1. You know, x to the power 0 is 1. 1 by 0, it is 1. You know, combination completely. 1 times x plus 1 by 1, it is 1. X to the power 0 is 1. 1 times 1 is 1. Then it is x plus y. This is the expansion for the x plus 1 raised to the power 1. If you have x plus y raised to the power 2, now what is n? N is 2. Use this formula, n 2c0 x to the power 2. You have to expand this one up to which? Up to ncn, y raised to the power n, plus what is n? It's 2c1 x raised to the power 2 minus 1. N is 2. 2 minus 1. Y plus, am I right? N is what? 2 c2. Now you find up to this part. Y raised to the power n. Y raised to the power n. N is 2. Listen here. N minus 1. And y is 1. Second y is 2. Like this one. Am I right? Yes. Now 2 combination with 0. It means 2 by 0. X to the power 2. Plus 2, 1, x to the power 2 minus 1, it's 1, y raised to the power 1, plus 2 with 2, and y raised to the power 2. Now you can simplify this one. It is 2 combination with 0, it's 1, and x square plus 2 by 1, it's 2, xy plus 2 by 2, it's 1, y square. Now, how you can expand x plus y raised to the power 2? It's x square plus 2xy plus y square. If you have x plus y raised to the power 3, use this formula. 3, 0, x to the power 3 plus 3 c1 x to the power 3 minus 1, it's 2 y plus 3 c2 x to the power n minus 2, 3 minus 2, it is 1 y square plus 3 c3 x to the power n minus 3, n is 3, 3 minus 3, it's 0, x to the power 0, y raised to the power 3. Now simplify this one. 3 combined with 0, it's 1. 1 x cubed plus 3 by 1, it's 3. 3x square y plus 3 with 2, it's 3 x y square plus 3 with 3, it's 1. 1 with this one, it's 1. 1 times y to the power 3, it's y to the power 3. Now you will have x plus y raised to the power 3. The expansion is x cubed plus 3x square y plus 3xy square plus y cubed. If you have x plus y raised to the power 4, now use this formula. 4c0 x to the power 4 plus 4c1 x to the power 4 minus 1, 3y plus 4c2 x to the power 4 minus 2, it's 2y square plus 4c3 x to the power 1 y cube and 4c4 x to the power 0 y to the power 4. If you simplify 4 by 0, it's 1. 1 x to the power 4. Do not write y 1. Plus 4 by 1, it's 4. X cubed y plus 4 by 2, it is 6. X square y square. How you can simplify? N by r or NCR. It's n factorial n minus r factorial times r factorial. For example, if we have 4 by 2, this one, then this is 4 factorial, 4 minus 2, 2 factorial times 2 factorial. Now 4 factorial is 4, 3, 2, 1. 2 factorial is 2 times 1, and this 2 factorial 2 times 1, 2, 1, 2, 1, and this 2 with this one, 2, 3, it's 6. 6 x square y square. Now 4 with 3, it is 4 x y cube, and plus 4 combined with 4, it's 1. 1 times 1, 1. 1 times y to the power 4, it is y to the power 4. Second, the last one, if we have x plus y raised to the power 5. Now, what's the expansion? 5c0 x to the power 5 plus 5c1 x to the power just you have to decrease the power of x by one term. After 5 we have 4, and increase the power of the second term by 1. Now you have 5c2 x, decrease this one by 1 power, it's 3 y, increase this one by one more. The first we have 1 more, it's 2. Now we have 5c3 x to the power what? 2 y to the power 3. Am I right or not? Yes. Now 5c4 x y4 and 5c5 x to the power 0 y to the power 5. This is the expansion. Now I think if you want to find the coefficient of this x plus y, the first coefficient is 1 and the second one is also 1. If you find the coefficient of x plus y raised to the power 2, the first coefficient is 1, the second is 2, and the last one is 1. X plus y raised to the power 3, the first coefficient, it is 1, second 3, and the third term it's 3, and the last term it's 1. If you find x plus y raised to the power 4, the coefficients is 1, 4, 6, 4, 1. But simple, we can define, or we can find the coefficients according to Pascal triangle. Now what that one is, write it, we will come. By the way, what Pascal triangles means? Pascal triangle is used for finding the coefficients of the binomial expansion, in which maybe a plus b or x plus y, whatever is x plus y raised to the power n. This power index should be a positive integer number. Now in here we have the index, and here we have the coefficient. By the way, if index is 0, now coefficient is 1. If index is 1, expand this one by 1 and expand this one by 1. If index is 2, expand this one by 1, sum these two, it's 2, and expand this one by 1. If index is 3, expand this one by 1, sum these two, you have 3, sum these two, it's 3, and expand this one by 1. If you have 4, expand it by 1, 1 with 3, it's 4, 3, it's what? 6, 3, 1, it's 4, and 1. If you have 5, expand this one by 1 and sum these two, 5, it's 10, 4 plus 1, it's 5, and expand this one by 1. If you have 6, now this is 1 with 5, it's 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 with 5, 15, and this one is 6, and this one is 1. What does it mean? If you have x plus y raised to the power 5, for expansion of this binomial, you will have the coefficient. The first one is 1, the second one is 5, the third one is 10, the fourth is 10, the fifth one is 5, and the last term is 1. If you have x plus y raised to the power 4, now what are the coefficients? Look to your notebook, please. First one is 1, second one is 4, third term is 6, fourth is 4, and fifth or last one is 1. If you have x plus y raised to the power 3, now the coefficients are 1, 3, 3, 1. It means by usage of Pascal triangle, indeed you are able to find the coefficients of a binomial expansion in which the power index is a positive integer number. Am I right? And one thing you have to know, whenever you are finding the x plus y raised to the power 4, these coefficients, except for the first and for the last term, the other terms are the summation of the preceding row. For example, if you want to find x plus y raised to the power 5, now what the coefficients are? Except for the first and except for the last, the other terms like 5, 10, 10, and this 5. These are the summation of the preceding row. Now, what is the preceding row for x plus y raised to the power 5? It is 4. Now, the summation of these row is the coefficients for x plus y raised to the power 5. For x plus y raised to the power 6, the summations of the preceding row, which is 5, those are the coefficients for x plus y raised to the power 6, but except for the first term and for the last term. I think you have got. Write it, please. By the way, note this one. The first and the last term, they started by 1 in every binomial expansion. Second, the coefficients except for the first and the last. The coefficients except for the first term and the last term are the sum of preceding row. I think you have got. For example, one thing you have to know is if you have x plus y raised to the power 4. Now, what are the coefficients? It is 4c0, 4c1, 4c2, 4c3, 4c4. 4c0, 4c1, c2, c3, and c4. If we have x plus y raised to the power 5. Now, what are the coefficients? It is 5c0, 5c1, 5c2, 5c3, 5c4, and 5c5. If you have x plus y raised to the power 6, now what are the coefficients? 6c0, 6c1, 6c2, c3, c4, c5, and c6. You can write, for example, this term like 4 by 0, comma, 4 by 1, 4 by 2, 4 by 3, 4 by 4. Now, these are the coefficients for a binomial expansion. How we can prove the general formula for the binomial expansion? Write it, we will come. By the way, come to prove for the binomial expansion. By the way, if we have x plus y raised to the power n, now what is the expansion formula for this one? You have nc0 x to the power n, nc1 x to the power n minus 1 y to the power 1, plus nc2 x to the power n minus 2 y to the power 2, plus nc3 x to the power n minus 3 y to the power 3, up to nc n x to the power 0 and y to the power n. Am I right or not? Yes. Now we have to prove this formula. Use mathematical induction. In mathematical induction, you have three things. What are those? First, you have to define whenever you are putting instead of n, 1. Second, define for the m term. Number third, if you can define that formula for the m plus 1 for m plus 1 terms, then that would be correct. What do I mean? I mean that if you have an x plus y raised to the power n, first you have to define x plus y raised to the power 1. Instead of n, define for the 1. For 1, we have 1 c0 x to the power 1 plus 1 c1 x to the power 0 y to the power 1. Now if you put instead of 1 c0, the combination, the result of this one, it is 1, I mean x to the power 1 plus y to the power 1. Is it correct? Yes. Second, you have to define for m term. Now, what is the expansion of this binomial expansion for the m term? You have m c0 x to the power m plus m c1 x to the power m minus 1 y, am I right? m c2 x to the power m minus 2 y to the power 2, m c3 x to the power m minus 3 y to the power 3, up to m c4 x to the power m minus 4 y to the power 4, up to what? Up to m cm x to the power 0 y to the power m. Is this one the expansion for the x plus y raised to the power m? Yes. Now, if this is our first equation and this is our second equation, multiply both sides. I mean, third, you have to find x plus y raised to the power m plus 1. If this formula or this formula is defined the same for m plus 1, then this formula is correct for x plus y raised to the power n. I mean, x plus y raised to the power 1, this formula is correct, maybe. x plus y raised to the power m, this one may be correct. But if we can find the proof of this formula for m plus 1, then it means that this formula, if this one satisfied for m plus 1 index, then this is the correct for m, for 1, and for every n power. This is the method for mathematical induction. Now, how you can find this x plus y raised to the power m plus 1? You have to multiply equation first with equation second. Multiply equation first with equation second. It means this term with this term. So you will have what? X plus y raised to the power 1, x plus y raised to the power m. Am I right? Yes. Now this side, x plus y with this one, m c0 x to the power m, m c1 x to the power m minus 1, y, m what? m c2 x to the power m minus 2, y square, m c3 x to the power m minus 3, y to the power 3, up to m cm y to the power m. Now in here the bases are same, then x plus y, the powers should be at m plus 1. Now multiply the first term with the all terms and the second term with the all terms. Now you have x with this one, so you will have mc0 x to the power what? M times x plus x with this one, mc1 x to the power m minus 1 y times x plus this x with this one, mc2 x to the power m minus 2 y to the power 2 times x plus this term with this one, mc what? c3 x to the power m minus 3 y to the power 3 times x. Like this one, we have another term in here. It is mc4 x to the power m minus 4 y to the power 4 x up to this one. X should be multiplied with this one plus mcm y to the power m with x. The first term is finished. Now come to the second one. This plus y or positive y should be multiplied with the all terms of this bracket. So positive times with this positive, it is once again positive. Y with this one, we have mc0 x to the power m y. Am I right? Yes. Now this one with this one plus mc1 x to the power m minus 1 y, and we have another y, plus this one with this one, mc2 x to the power m minus 2 y square with y. This one with this one, you have mc3 x to the power m minus 3 y to the power 3 times y up to the last one, this plus and this y with this term, you have mcm y to the power m y. Now look, we have mc0 x to the power m times x. It is x to the power m plus 1. Am I right? Yes. In here, x to the power m minus 1 with this x. So we have the bases are same. M minus 1 plus 1, it is m. So you can write here m. Am I right? Yes. In here, look, x to the power m minus 2 with this x. This is m minus 1. Here, x to the power m minus 3 with this x, it's x to the power m minus 2. In here, you have m minus 3. And come to here, x to the power m, this one, it's y square. This one, it's y cube. This one, it's y to the power 4. And this one, it's y to the power m plus 1. Is it right? Yes. Now, this is what? This one is this one. The bases are same. M with this one, it's m plus 1. Am I right? Yes. So write it here also. This term multiply with this one, it is like this one we can find. Now, do we have x to the power m times y in here? X to the power m times y? Yes, we have. So these are same. The terms are same. It means we can sum these two parts. I mean, plus, you can have this coefficient mc1 plus mc0 times x to the power m y. These are same. Do we have mx to the power m minus 1 y square? Yes, we have here. Now these two terms we can sum. I mean the coefficients must be added. mc2 plus mc1 x to the power m minus 1 y square. Do we have x to the power m minus 2 y cube? Yes, we have here. It means these two coefficients can be added. So we have mc3 plus mc2 x to the power m minus 2 y cube. Like this one, this term we don't have in here. It means the last term also we don't have in this expansion. So the last term would be mcm y to the power m plus 1. Now, one thing more that you have to know is, can we write this one m plus 1 c0 x to the power m plus 1? Yes, we can write. Why? Because this one means m by 0 and this one means m plus 1 by 0. Both are the combination of every m number by 0 or m plus 1 number by 0, it's 1. It means you can write mc0 like m plus 1 c0 raised to the x raised to the power m plus 1. Yes, it's correct. Second, in here, look, can we add these two? Yes. What does it mean? It means that we have m by 0 plus m by 1 plus m by 0. Now, what is the combination of this one? If we have in here, in our term, if you have one difference, then pick the biggest one, it is 1, and add this m by one number, m plus 1. What do I mean? If you have 2 by 0 plus 2 by 1, now what is the combination for this one? It is pick up the largest one, which is 1, and add this term by 1 more. It means 2 plus 1, it's 3. Then 3 by 1 has the same result of the summation of these two. If you have, for example, 5 by 0 plus 5 by 1. Now, what is the result? The result is, pick up the largest one, which is 1, 5, just add the n with one term more, it is 6. If you have, for example, 7 by 2 plus 7 by 3, pick up the largest one. Why? Because we have these difference by one number. So pick up the large, it's 3, and add this one with one more, it is 8. Am I right? I mean, try to use this formula. In here, if we have, for example, 15 by 12 and 15 by, for example, 11. Now pick up the largest one. The largest one is 12, and this 15, add this one by one more, 16. It means you can use in here this formula. So how can you write? This one is like this one, and this one is like this one. So it is m plus 1. Pick up the largest one, which is 1. X to the power what? M y. In here also you have the difference between these two is 1, and the n terms are same. So n terms should be added by 1, and in this one you have to choose the largest one, which is 2. Now what is the term? X to the power m minus 1 times y square. Am I right? Yes. In here, plus the difference between these two are 1, 3 with 2. How many difference do we have? 1. And the m terms are same. So choose the largest one, which is 3, and add this one with 1. So the last one, the term is x m minus 2 y to the power 3. Am I right? Yes. I have to erase this side. Now plus 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 up to, can we write this one m plus 1 c m plus 1? Yes, you can write. Why? The combination by m and m plus 1 by m plus 1, they are same, times y to the power m plus 1. Now this is the result for what? This is the result for x plus y m to the power m plus 1. Now look, x plus y, this is x plus y. What is n? This is n. X plus y, m plus 1 is a number like n. So this is n. N c0 x to the power, this is n. This is this with this one, they are same, n, plus this is n c1 x to the power. What this one is? This is n minus 1. Why? Because n is what? N is m plus 1 minus 1. 1 with 1 we can cancel. Now we have m times y. The third term is m plus 1. This is n. This is n. c2 x to the power. What this one is? This is n minus 2. Why it's n minus 2? Instead of n, you have to put m plus 1. Instead of n, x to the power n minus 2. We can have x to the power m plus 1 minus 2. So you have x m minus 2 with this one. It's minus 1. Am I right? Yes. Then you have y square plus this is n c3 x to the power. What this one is? It's n minus 3 y raised to the power 3 up to this is n cn y, and this one is n. It means if you define this one but for the x plus y raised to the power n, and you can define this one for the which index, for the m. Then if you are able to define such formula for x plus y raised to the power m plus 1, then this can shows that this formula is correct by usage of mathematical induction. I think you have got. Write it, please. By the way, some important points. You have to know in binomial expansion. First, if you have x plus y raised to the power n, now what is the general formula for this one? It is nc0 x to the power n, nc1 x to the power n minus 1 times y, nc2 x to the power n minus 2 y raised to the power 2, nc3 x to the power n minus 3 y raised to the power 3 up to ncn x to the power 0 y to the power n. Am I right or not? Or delete this one, y raised to the power n. Now we can use a notation like summation of r equal to 0 up to n cr x to the power n minus r y to the power r. This notation can be used for this formula. Why? Summation means addition of these terms. N is, this is n, and r starts from what? From 0. The first one is x to the power n minus r. R is what? 0. So n minus 0, it's n, and y to the power 0. What do I mean? For example, this one means n c0 x to the power n minus 0 y to the power 0. Y to the power 0 is 1, and this one doesn't mean. So you find nc0 x to the power n. The second term, n r is what? After 0 we have 1 x to the power n minus 1 y to the power 1. The third term, nc, after 0 we have 1, after 1 we have 2 x n minus what is r? R is 2 and y is 3, plus we have once again n c, after 2 we have 3 x to the power n minus 3 y to the power 3 up to which term? Up to n term. So you will have ncn x to the power n minus n y raised to the power n, and this n minus n is 0, x to the power 0 is 0. So look, the first term, the second, the third, the fourth. We mean that this notation can be used instead of nc0 x to the power n, nc1 x to the power n minus 1 up to ncn y raised to the power n. Am I right or not? Yes, you have got. Second, you have to know that how many terms do we have in x plus y raised to the power n. The number of terms n x plus y raised to the power n is n plus 1. What does it mean? If we have x plus y raised to the power 3. Now, what's the expansion for this one? It's x cubed, 3x squared y, 3xy squared plus y cubed. Now, how many terms? 1, 2, 3, 4. And this 4 is 3 plus 1. How many terms do we have? 4. And x plus y raised to the power 3. How many terms do we have in x plus y raised to the power 5? We have 6 terms. I think you have got it. Number 3. The sum of x and y is n. The sum of x and y is n. What does it mean? I mean the sum of power of the x and y. N is 3. This is 3. What is the power for y? It's 1. 2 with 1, it's 3. It's 1. 1 with 2, it's 3 and 3. If we have x plus y raised to the power 4, now you have the expansion in here. In every term, the addition of the power of the x and y, it is what? 4. Whatever the number is, that is the summation of the x and y. Number 4, x decreases by unity. Hence, y increases by unity in each term. What does it mean? First, we have x to the power 3. For the next terms, x decreases by unity. It's 2, it is 1 and 0. Y increases 1, 2, 3. If we have x plus y raised to the power 5, now the terms are, first x is defined by 5. For the next terms, x decreases by 1, y increases by 1. This decreases by 1, 5 decreases by 1, it's 4. For the next term, x is 3, y is 2. For the next term, x is 2, y is 3, x is 1, y is 4, and x is 0, y is 5. I think you have got. We had some important points. The first one, we use that notation. The second one, how many terms do we have? We have n plus 1 terms, and the summation of the power of the x and y, it is n, and x decreases by what? Unity. Hence, y increases by unity in each term. Write it, please. We have some particular case for binomial expansion. First, what is x minus y raised to the power n? Instead of plus y, put minus y. Then you will find the same formula, n c0 x to the power n minus n c1 x to the power n minus 1 y n plus n c2 x to the power n minus 2 y square minus n c3 x to the power n minus 3 y to the power 3 plus dot up to plus minus 1 raised to the power n n cn y to the power n. How you can define this one? This is, can we write this one x plus minus y raised to the power n? Yes, we can write. Now, what is the formula for x plus y raised to the power n? For x plus y, for x plus y raised to the power n. You have nc0 x to the power n plus nc1 x to the power n minus 1 y raised to the power 1 plus nc2 x to the power n minus 2 y raised to the power 2 nc3 x to the power n minus 3 y3 up to ncn y to the power n. Now instead of y, you have to put minus y. If you put in here minus y, this minus comes here. Am I right? If you put instead of this one minus y, minus raised to the power even number, it's plus. Minus here, minus raised to the power odd number, it's minus. And up to the last one, if this n is even, then it's plus. And this if this n is odd number, in here we have minus. I mean, just it is the same with x plus y raised to the power n, but the sign, the first one is plus, second one minus, plus, negative, plus, negative, plus, negative, or positive, negative, like this one. If you have x plus y raised to the power 3, this is x cubed plus 3x square y plus 3xy square plus y cube. But if you have minus, then the first one is positive, the second one is negative, positive, negative. If you have x minus y raised to the power 4, it is x to the power 4 plus 4x cubed y plus 6x square y square plus 4xy cube and plus y raised to the power 4. But if you have, this is the plus, but if you have minus, so it's plus, the second one is negative, positive, negative, and like this one, positive. I think you have got. This is the first particular case for the x minus 1 raised to the power n. Write it, we will come to the second one. Second, if you have x plus y raised to the power n plus x minus y raised to the power n. If you have this one, x plus y raised to the power n and x minus y raised to the power n. Now, what formula we can use? What formula we can use? First, you know that this first equation we had x plus y raised to the power n, it is nc0 x to the power n plus nc1 x to the power n minus 1 y plus nc2 x to the power n minus 2 y raised to the power 2 up to plus ncn y raised to the power n. The second equation we had x minus y raised to the power n. What is the formula? nc0 x to the power n minus nc1 x to the power n minus 1 y. It's the same, but the signs, the first one is positive, negative, positive, negative, like this one. nc2 x to the power n minus 2 y to the power 2 plus or minus up to plus or minus minus 1 raised to the power n and cn y raised to the power n. Now, by adding these two, you can find this one. So, if you add these two, now what do you find? This one we have two terms. This one with this one cancel. This we have two terms. The third one is cancel. Y after plus we have negative. It means that we have two terms of this one and the two terms of the this one, and we have another two terms of for the what? For the even numbers. I mean, you can use two terms of nc0 x to the power n plus nc2, not c1, because odd numbers are getting cancelled, but even number we have two terms, nc2 x to the power n minus 2 y to the power 2 plus n c3 or c4? c4. n c4 x to the power n minus 4 y to the power 4 y. In here, if we have 2, this is 2 minus 2 and this is 2. If we have 4, n minus 4 y 4 up to the last one, n cn y raised to the power n, and this n is even. This n is what? Even number or odd number? It is even, if this one is even. Else we can write plus dot dot dot. If we want to define x plus y raised to the power n minus x to the power x minus y raised to the power n. Now, how can you define this one? It means these two formula should be subtracted with each other. This is minus, minus, plus, like this one. So you will have this one, and this is getting cancelled. How many terms do we have in here? 2 terms. For what? For the odd number. We have n c1 x to the power n minus 1 y raised to the power 1. This odd number is getting cancelled, and the next one is this even number is getting cancelled. The next one is odd number, so we have plus n c3 x to the power n minus 3 y to the power 3 plus n c5 x to the power n minus 5 y to the power 5 up to the last term. We have some particular cases for the binomial expansion. For the x minus y raised to the power n, you can use this formula. It's the same with the plus, but the signs, the first one is positive, negative, positive, negative, positive, negative, like this one we can put. If you want to find x plus y raised to the power n plus x minus y raised to the power n, you can use this formula. Where did you find this formula? Just by adding this equation with the first one. If you want to find the subtraction of x plus y raised to the power n minus x minus y raised to the power n, this is the formula. And where did you find? From the subtraction of the second formula with the first. And this is the addition of the first and the second. So in here you have which terms? The odd terms, and in here you have even terms. I think you have got. Write it please. Then we will count how many terms do we have in here and how many terms do we have in this expansion. You know how many terms do we have in x minus 1 raised to the power n? How many terms do we have? We have n plus 1 term. But how many terms in here do we have and how many terms in here do we have? Write it, we will come. 4. X plus y raised to the power n plus x minus y raised to the power n, and x plus y raised to the power n minus x minus y raised to the power n. If n is odd number, then how many terms do we have? You have n plus 1 divided by 2 terms. 5 or in 4, x plus y raised to the power n plus x minus y raised to the power n. X plus y raised to the power n and x minus y raised to the power n. If n is even number, on that occasion, for this one you have n divided by 2 plus 1 terms. You have n divided by what? N divided by 2 terms. But if you have x plus y raised to the power n minus x minus y raised to the power n is even, then you have n divided by 2 terms. It's very important. What do I mean? For example, if I have x plus y raised to the power 3 plus x plus y raised to the power 3. Now, how many terms do we have? N is odd number. Then we have n plus 1 divided by 2. What's n? It's 3. 3 plus 1 divided by 2. 3 plus 1, 4. 4 divided by 2, 2. Then we have 2 terms. If you expand these two, how many terms do you find? You can find 2 terms. If you subtract this one, also you can find how many terms? You can find 2 terms. But if you have like this one, x plus y raised to the power 4 plus x minus y raised to the power 4. Now this is the case. N is even. How many terms do we have? N divided by 2 plus 1. What is n? N is 4 plus 1. No, 4 divided by 2. 4 divided by 2 plus 1. 4 divided by 2, 2. 2 plus 1, 3. Then it has 3 terms. But if you have this case, x plus y raised to the power 4 minus x minus y raised to the power 4. How many terms? First check n is even or odd number. It's even number. If this one is even, n divided by 2. N is what? 4. 4 divided by 2, then it has 2 terms. If you do not believe, then please expand this one, then sum or subtract, then count the terms. Should I do? Yes, the first one. For example, this is x cubed plus 3x squared y plus 3xy squared plus y cubed, and plus, this is plus, this is once, this is x minus, x minus. First should be positive, second should be negative. Now, what's the expansion for this one? It's x cubed minus 3x squared y plus 3xy squared minus y cubed. Now, x squared with x squared, 2x squared. This one with this one is cancelled. 3xy squared, 3xy squared. It's 6xy squared. Y is getting cancelled. Now, count. How many terms do we have? 2 terms. If n is odd number, how many terms? For addition and subtraction, we have n plus 1 divided by 2 terms. If n is even, then we have 2 cases. For summation, we have n divided by 2 plus 1 term, and for subtraction, you have n divided by 2 terms. Write it, please. Number 5 in particular case. Number 5. If you want to expand 1 plus x raised to the power n. What's the expansion for this one? This is x, this is y. So you have the formula n c0 x to the power n. X is 1 to the power n plus n c1 x, which is 1, n minus 1, x to the power 1, x to the power 1, plus n c2 1 raised to the power n minus 2 x square. Like this one, you have up to n cn x to the power n. Now you can write here 1 plus x raised to the power n, n c0, it's 1. 1 raised to the power every number, it's 1. 1 times 1, 1. Plus, now what is the simplification of nc1? nc1, it means n by 1. Now you have n factorial, n minus 1, n minus r factorial times r factorial, which is 1 factorial. So you can expand this one. It is n minus 1 factorial divided by n minus 1 factorial 1. This one is cancelled, so you have n what? X plus. Now what is nc2? nc2 means n by 2, so you have n factorial n minus 2 factorial times 2 factorial. Now if you simplify, expand this one, n minus 1 n minus 2 factorial divided by n minus 2 factorial times 2 factorial. So this is cancelled. n minus 1 divided by 2, n minus 1 divided by 1, 2 factorial x to the power 2. The second one is n minus 1 n minus 2 divided by 3 factorial x to the power 3. Am I right or not? The next one, n minus 1 n minus 2 n minus 3 divided by 4 factorial x to the power what? 4. Like this one. And what do you think what the last one is? The last one is x to the power n. You can use this formula for 1 plus x raised to the power n. This formula mostly we use in order to find Euler number, inshallah, in higher mathematics. Where did I find this formula? It is by usage of binomial expansion. Number 6, if you have 1 plus 1 minus x raised to the power n, once again the same, it's 1, the next term is negative nx plus n minus 1 divided by 2 factorial x to the power 2. First we have positive, negative, positive, negative, same, n minus 1 n minus 2 divided by 3 factorial x to the power 3. After negative we have positive, n minus 1 n minus 2 n minus 3 divided by 4 factorial x to the power 4 minus, like this one, and minus 1 raised to the power n x to the power n. This is the general formula for 1 plus x raised to the power n and 1 minus x raised to the power n. Write it please. These were the particular cases for the binomial expansion. Some important points I have to declare is, which is very important. First, for defining any term, you can use this formula. TR plus 1 is NCR x to the power n minus r and y raised to the power r. This formula you can use for any term you have to define. For example, if we have x plus y raised to the power 4, now it is x to the power 4, 4x cubed y, and you have 6x square y square, 4xy cubed plus y to the power 4. This is the first term, this is the second term, this is the third, this is the fourth, and this is the fifth. If I want to say what is the third term, what is the third term? You say that it is 6 square y square plus. Instead, you can use this formula. First, this is the term that which we want to find. I mean r plus 1, put it equal to 3, then r is what? 2. Now, what is n in this one? In this expansion, n is 4, x is x, y is y, then put the formula t instead of r, 2 plus 1, n is 4, c, r is what? R is 2, and x to the power 4 minus 2, and y raised to the power 2. Then simplify this one. This is the term that we want to define. 2 plus 1, it's the third term, which 4c2, the combination of this one is 6, x, 4 minus 2 is 2, y is 2. This is 6 square, y square. This is the third term, and I think it's correct. Second important point that which we have in binomial expansion is it was the first one. Second, whenever you are finding the middle term, there are two cases. First, if n is even, in which binom nx plus y raised to the power n. If you want to find the what? The middle term. Then what is the middle term in x plus y whenever n is even? The middle term is n divided by 2 plus 1 term. This is the middle term. For example, if we have x plus y raised to the power 16. Now, what is the middle term? The middle term is 16 divided by 2 plus 1 term. 16 divided by 2, it is 8. 8 plus 1, it's what? 9. Then the 9th term is the middle term. Why? Indeed, it has how many terms? 17. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17. So this is the middle term. And I think how many parts do we have in here? 3, 4, 5, 6, 7, 8. For the right side, 1, 2, 3, 4, 5, 7. No. 6 divided by 2, 8, 8 plus 1, 9. The 9th term, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 also we have. 15, 16, 17. How many terms do we have in this side? 8. How many terms do we have in this one? 8. So the 9th one is the middle term. I mean, if n is even, then n divided by 2 plus 1, this is the middle term. Am I right? Yes. But if we talk that n is what? N is odd number. On that occasion, we have two middle terms. First one is n plus 1 divided by 2 and n plus 3 divided by 2. These are the middle terms for the n is even. What do I mean? For example, if we have x plus y raised to the power 5, then how many terms do we have? We have 6. 1, 2, 3, 4, 5, 6. Am I right or not? How many middle term do we have? Two middle term. N plus 1 divided by 2. What is n? N is 5. 5 plus 1, 6. 6 divided by 2, 3. And 5 plus 3, 8. 8 divided by 2, 4. 3 and 4 are the middle term. These are the middle term. Indeed, we have two terms for the right side and two terms for the left side. So this is the middle term. I think you have got. And one thing which is very important, number 3, if we have x plus 1 divided by x raised to the power 2n. X plus what? Plus 1 divided by x raised to the power n, where x is not 0. Why? Because if x is 0, on that occasion we cannot define this fraction. So the middle term for this one is 2n plus 1 divided by 2. Or we can write this one plus 1, 2. 2 with this 2. With this one, it's getting cancelled. N plus 1. This term. And also, it's a constant term. which is the coefficient is 2ncn. If we have x plus 1 divided by x raised to the power 2n, where x is not 0, the middle term is n plus 1 term, and that is a constant number. For example, if you have x plus 1 divided by x raised to the power 4, this one is what? 2n. This is 2n. 2n is even number. On that occasion, you can define a constant term, and this constant term is the middle term, and that is the coefficient is 2ncn, and the term is n plus 1 term. What do I mean? If you expand this one, this is x to the power 4 plus 4 x to the power 3, 1 divided by x, plus 6x square 1 divided by x square, plus 4x 1 divided by x cube, plus 1 divided by x to the power 4. This is getting cancelled. So you will find x to the power 4. This is getting cancelled, 4x square plus 6, plus this is getting cancelled, 4 divided by x square plus 1 divided by x to the power 4. This is the middle term. Now what the middle term is? N plus 1. 2n is 4. So n is what? 2. The middle term is n plus 1. 2 plus 1. 2 plus 1, third. First, second, third. This is the middle term. How many terms do we have? 2. 2. And this is what? A constant number also. This constant number you can find from this formula, 2ncn. What do you mean 2ncn? It means do not expand. The power is less, so the expansion is easy. But if we have x plus 1 divided by x raised to the power 100, 100 is even. Where is the middle part? The middle part, you can use this is 2n should be equal to 4. N is what? 2. So in here 2, and instead of n you use 2. C, and instead of n 2. 2 to 4. C 2, and 4 by 2. Now you can simplify 4 by 2. 4 by 2, 4 factorial. 4 minus 2, 2 factorial times 2 factorial. It is 4, 3, 2, 1, 2, 1, 2, 1. Cancel. 2 times 3, it's 6. This one is 6. I think you have won. By the way, it was our lecture, general information on the binomial expansion. Inshallah, for the next lectures, we will come on the best examples with the best explanation. Allah Hafiz.